I'm going to be continuing to work on my CAD library, working with some parametric surfaces and messing around with just a few things related to rendering those into an SVG canvas. Let me start a timer here for a second. We're good to go. Yeah, not much to really say. Just gonna get started. I hope my brain's in the game today. So I don't think I showed this on stream, but I just messed around and made a kind of cool little random generated art thing, if you want to call it that, and I think it looks pretty neat. And it changes based on, what are we looking at here? This, if I save this, it'll regenerate a random set of points and it'll redraw it. And if I do this even, it turns into even fewer total points. I just think that's kind of fun. A little silly, right? But pretty neat if you ask me. So there's a cylinder. Which well, let's see here. Oh, that's not what I need. I can zoom that by doing, what are we doing here? Yeah, here. Scale it 5 times or so. Sure, that's good. That'll work, right? Yeah. And then here I can do SVG/translate. And then this is 2D, so I just move it down, what, 100? Something like that. Translate. There, random shape generator thing. That's kind of fun for no real reason. It just is neat to me. Let's double that. Let's increase the number of points we take. I think that's pretty cool. Whew. Well, that was silly of me. Oh boy. Oh. Right. I do wonder actually what happens if I take just a normal grid instead of random grid here. What will this look like? It should work. Yeah. Right, so that's pretty cool, right? You can see that it's supposed to be an actual, like you can tell more easily that it's supposed to be a cylinder there. Wonder what the sphere looks like with this over it. Oh, scale it only by 1. Oh yeah, that even looks pretty cool. So I am running a just for the fun of it, the opacity is randomly changed, but I don't really need it to. Excuse me. If I make opacity 1, then it's sort of a closed sphere. But the rendering is going to be wrong because of some like the order of the triangles is like it's not being painted on necessarily in the correct order from the camera. So there's eventually there's going to be a need for me to do stuff like hidden line removal. There's going to be some more complicated algorithms to get proper line renderings on of objects, but I'm not going to worry too much about that right now. What I am going to do, just for a bit of fun first, is figure out an animation. I want to try some animation stuff. And the reason is I want to use animations, or I think it might be cool to use animations to slightly rotate 3D objects like this back and forth to help with the mental representation. I don't know if that makes any sense, but I'm just going to start messing around with SVG animation first and kind of figure things out from there. So if I just comment this out here, I really should clean up, this is a scratch document anyway, but even so, it's probably smart to clean it up from time to time. I still have to, you know, do that, but let's do animation test is what we'll call this here. Yeah. Okay. So then all I have to do is get rid of the rectangle. Okay, this should change to show this. Yeah, okay. We're good there. Let's make the stroke color slate gray is kind of nice. It's good enough for now. Fill, none. Oh, let me do, just to save those colors. Actually, I don't need to do that, that's silly. To keep it a little bit clearer, fill, none. Those colors are up in this. I copied and pasted it anyway, so it's theoretically fine. Okay, so that's a sphere, but actually, why am I even doing that? Let me do something easier here. Let me do let's just get rid of everything here. let's see. SVG animations tests. This is figure number 1, but you could change it to figure 2 and that would adjust right here. Figure 2, yeah, perfect. Okay, so this here, SVG slash line. Let's do a line from $50, $50 to $250, $250, right? That should work. Oh, I may have missed a paren there. Okay, that's working. Let's zoom this out again a little bit. There. That's working, but I do need to do SVG slash color. Let's actually, I always forget these color codes, but why not use one from here? One of my favorite color themes, Nord theme. It just looks really nice in my opinion. That colors that, and that should work okay. And then I should see a line kind of like this. Oh, I went the wrong way on it. Oh, that's right, because this here, this function shifts everything so that the 0, 0 point is right in the middle here. Actually, let me add here axes 2D so they have that reference point. No? Oh, it's maybe not SVG, but D. There we go. Right, so this cross point right here is 0, 0 in 2D space, which means I can do this, -50, -50, 50, 50, and that is a diagonal exactly centered. Right, so now what I should be able to do is conj onto this thing. Actually, let me rewrite this just this way. So it's a one-liner here, and then I have to conj something here and then close it off. And this thing here is going to be animate, and I had something, did I delete it? I may have deleted it. Yeah. Oh, messy notes. That's just the way my brain's working these days. Probably should figure out a more permanent, good solution. Spend some more time studying all that kind of stuff. But my life's not working out quite that way to let me do all that at the time being, for the time being. Not an excuse, just a reality. Anyway, I'm not talking about anything important right now. Okay, there's animate motion is not what I need. But let's start here. So animate motion's pretty cool, but it's probably not gonna be exactly what I need. But that's gonna be okay. Although I could build something that creates an animate motion that calculates all of the paths for every single point in a grid so that you get a perfect rotation about an axis, but that's pretty intense. Let's start with something maybe easier. I just need an animation example here, because I forget. Nope, that's not what I meant to do. Let's see if this works here. Animate, this is what I'm looking for. Okay, so what you can do is put in an animate element inside an SVG element here. And then you can pick the attribute to animate. So where am I here? Let's have a look here. So this animate is just going to have a map full of attributes. So attribute name. And in this case, I want to just do, let's see here. Let's animate x2 with the values of, so we happen to know x2 is 50, so let's move it from 50 to negative 50 to 50. Duration, let's do 4 seconds. No, let's do 2 seconds. And then there's probably one here, repeat count indefinite, yeah. Repeat count indefinite. Okay, so that is the animate thing, conj that in. So let's see, that might work, unless I oh, there we go. So that is working. Okay, so can I use that? Attribute name. Are there other attributes that might be useful here? Let me think. Can you like create, how do you do SVG shape? Let's see. Yes, I'm familiar with all of these ideas. Yeah, okay. Let me go into here, have a look at polygon call for a minute here. If I do a list of 3 points, right, so polygon has points. I wonder if that, I wonder if this can work. It's gonna be weird, but I'm gonna try it to see what happens. Okay, so SVG polygon, let's do the points, let's do -50, -50, up to 50, 50. Oh, I have to do it in a list, of course, like this. And then this point will be 0, 100. I think that makes sense. Let's do this just for a moment. Oh, I think that might error out actually, because I'm conjing nothing. Oh, I also did this wrong. -50, -50 is the starting point, which is going to be here. I need x to be this, but y to also be -50. I wanted to make a isosceles triangle there. So what I'm going to do here is try to animate this with distinct value calls here. So let me actually go like this, copy this. So the attribute I'm animating is going to be points. The values I'm going to animate between are those, and those, but I'm going to do it so this point here is going to go from 100 where it's at now to 10 back to 100, and I want to see if this actually will animate. Something tells me it won't. Oh man, it actually does. That surprised me. I did not expect it actually to animate, so that's interesting. It's not animating the way I expected entirely, but oh no, that's right. This should be like that. Yeah. Well, okay. So let me think about how I can use this. So the idea I've got going on here, let's unanimate this for a minute. What I want to do now is actually run, let me just do the same thing here, path polygon, right? I want to actually try, I'm gonna try the same thing with a call to path polygon to see if it'll animate the D string value here. So that's the next thing I want to try. Where I'm gonna have this and this and this. Oops. Okay, they're all the same. So the middle one I have to change to have oh, I've used the wrong values, of course. Classic. Let's adjust that. Let's actually do this. Is there a smart way to do this? I don't know. We shall see. We shall see. Okay. Okay, this one here, I'm going to change this 100 to -50, and then that. So if I save this, it should appear no different, but still animate. Okay, it does. So that is really cool. So let me see now. What would be cool is if I ran, let me try something. Just for kicks, if I invert this triangle, right? If I make this starting point instead of -50, -50, it's -50, 50, 50, 50, 0, -100, and then make this the, oh, I could have just done it quickly right here, but that's okay. If I just paste that in there, I wonder what happens if I do that. Okay, that's pretty cool. So what you could even do is, right, if I do that and I do here svg/scale to 0.1, a tenth of this. Now this is a scaled down path. Let's see what that looks like just for fun. Okay, so now what I want to do, now what I would like to do is animate this triangle between its isometric projection and its front projection. So basically I want to animate rotating a 3D view of it kind of thing. So let me have a look and see if I can get that going. So we're gonna have what am I thinking about right now? Okay, we've got, so this transform method here, how does render triangulation work again? Takes a list of triangles, of course it does. So what I can do, actually, render triangulation of, if I define, if I define A as just this, okay, so then I can run render triangulation of A if it's in a list. That should work. No. Right, that's because I have to add Z to A. Yeah, so then I can do, so I can do this. There we go. Then I do drop Z of this, and then this I can do, oh wait a second, what happened? Oh, I have to do like this. Apply drop Z to that? Yes, and then that is B. Okay, so what I have here, oh wait a second, this is wrong. Let me get back to this point here. So drop Z of this gives me an incorrect answer because I've lost a point. So if I do drop Z of first of render triangulation, I think that'll fix it. There, no. What am I doing? What am I doing wrong here? Takes a list of points. Okay. Let's just go here. Render triangulation gets me a list. If I do first of this, right, I've got a list of points that is already, oh, it's already two-dimensional, of course, so def B as this, there we go. Okay, so now what I have is A and B. def b as into vector b, just so we're consistent there. So there we go. A is this, and b is that same triangle rotated into the 3D isometric view sort of thing. So what I want to do actually is take b into, I'm going to manually, just because it's easy right now, I'm going to manually do it like this. It's going to be 0 e to the negative 15, close to 0 is fine with me, negative 35.355, negative 70.711, and 9.013. And then the last point, same idea, 70.711, 35.355. Okay, that's a slightly easier B. And now all we do is run svg/path polygon on B, and that gets us this string here. Oops. Which I want to try paste into here. And I want to see it animate between those to see what happens. I don't know if it'll look good at all. Okay, so that's the front view. And that is the ISO view of it. So let's also go in here, svg/color pink, svg/path polygon, and here we will just copy this. So we have the right, so it's flipping it over, right? Is what it looks like anyway. This is very confusing with the axes as well. Well, actually, does axes 3D not exist? Where did I put it? Oh, axes ISO. Right. So let's unanimate this for a minute. I think I may have an inconsistency problem here. So wait, X should also be red, shouldn't it? I may have colored my 2D axes incorrectly here. Let's go axes 2D. Ugh, 3D axes, of Of course, that's ridiculous. Not what I meant. Yeah, so this is what I meant here. X is red, Y is green. So I have to flip these actually, because I do want X to be this way. So that does mean for me okay, that should work there. This should refresh. Did I not flip the color properly? What happened here? There we go. Okay. X is red, Y is green. Perfect. So now what I need to have a look at here is, if I undo this, put these back in, I need to check actually that okay, so it is at least working correctly here. So ignoring the blue here from the isometric axes, this is confusing to see, but all I'm looking at here is the point of the isosceles triangle was pointing down along, in 2D, along the y axis. And it is, in the isometric view here, it is also pointing along there. So that rotation applied between them, or that animation I should say between them, is landing correctly, which is a good thing. I'm wondering if, like, it doesn't actually appear to be, I don't know if it's what I need it to be though. Okay, so the next thought in my head is, well, let's, so what I want to do next actually is okay, I'm gonna mush together so what, how do I describe this? I'm gonna take B as the starting point, and I'm going to apply, actually no, A is this. If I do SVG slash rotate 180 degrees, SVG slash path polygon of A, I have a new set of points, which I could have manually changed because it's just 180, but that's fine. Then what I do, oh, actually let's do C is the inverted or the flipped of A. Yeah, does that make sense? Okay, let's do 50, 100, negative 50, 100, 0, negative 50 is C. Right, so D, then, so A and C are the front plane view of the triangle. A is pointing down, C is pointing up. Then B is the transform of A, and so now I just have to make C the transform, or pardon me, I have to make D the transform of C. Yes, that's right. Which I do by, let's just go back up through these commands here. So if I def D as first of render triangulation of add Z to C, D is now this set of points, which, does that make sense? B is this, D and B. Well, okay, so let's go ahead and give that a shot. So we can go to here now. And I can start B as this set. Of points. And then these animations will be SVG slash path polygon of B is this. First, skip the middle one and then put it at the end as well, so it cycles back and forth. And then SVG path polygon of D is the next one we need, which is for laziness gonna be a mess, but I should be able to determine relatively quickly if it's gonna work. Oh dear, what did I do here? Oh, right, there. Okay, so let's have a look. Let's see if that makes sense. Ah, okay, right. So this, so this won't work. So what it's doing is just tweening, I guess, the positions directly. It's not rotating between them, which actually, if you think about it, makes perfect sense. So what I would have to do if I wanted to animate things properly, oh boy, there's not really, I'm not sure there's really a good way for me to do that, except by, I don't think that's a good, I don't think there's really a way to do this. So I think what I'm actually going to do is abandon animations for the time being, because this is not quite what I need. Right, and if I animate a scale, or pardon me, a transformed rotation, it will not do what I need, because it will only work in the 2D sense. So it'll be incorrectly rotating the lines like this, but it should rotate them about the 3D axis. But that's not gonna work. So this is an attempt at what I wanted to do was have a thing where I could put an animation on an object and have it subtly go between, like rotate just back and forth a little bit like this, to get a sense of the 3D, just by using default SVG animations. But I don't think it's going to work the way I want it to, judging by how this is tweening. So, and of course that actually makes perfect sense. right? You can tell what it's doing. This point here, like the long point of the triangle, is just moving in a straight line between its starting point and its end point. And by straight line, I mean like in the XY plane, not in the fake 3D space that I've provided it. So that's out. So let me go ahead and get rid of that. This points test thing I'm gonna get rid of as well. Animation, oh, SVG tests I wanna pop back in. Points test is deleted. And animation test we'll get rid of, which is good. A good failure. I like that. That's nice. Sounds silly to say it that way, but it's very good. I forgot. There we go. Okay, so PA and PB, I don't even remember what those are for, so let's get rid of them. Arc tests will be important because I haven't fixed that actually yet. Spawner was on button click example. That may be good. Let's go here. Sure, that makes sense. Mount. Yeah, sure. Why not? Okay. This isn't very clean. Okay, so we've got the globe back on there. It's pretty nice. Let's see. What I actually am gonna do is make a better grid function that I can use to perfectly map over parametric surfaces that go from 0 to 1. So how I want to do that is by doing, if I go into here, where did I put it? Oops. Triangulate. Oh, I forgot where I put that function. Okay, so I've got, well, let's have a look. Oh, DT, I put it in the Delaunay triangulation, of course, which maybe, let's do, let's actually, so I'll leave that in there, but that triangulation thing I have to fix up anyway, so, or put, it needs work. What I can do here is go instead to right here. Parametric space. Does that make any sense? It's fine enough for now. Clojure, tangle into source. This is in the draw stylo / draw.cljc. Is that correct? Source stylo draw cljc. Yes, it is. And we paste parametric grid That's probably a bad name for it, but all I'm going to do here is assume it's going to assume that the parameters are from 0 to 1 always, and what you do is nx and y, which means you divide a line from 0 to 1 into n x spaces, n x cells and y cells. So, right, if n is 10, right, you just do float, you divide 1 by 10, so you have 0.1 is your grid step. Does that make sense? I think so. And you can do range is 0 to 1 with a step. Yeah. So the obvious problem here, right, is floating point errors and things like that. So I don't have a solution that pops to mind. But let's go and give it a try. So for x and y is range. The range in both cases is always going to be 0 to 1, and then the step is going to be x step, which I have to calculate 0 to 1, y step. Right, so then you just get here, for each position, you get it should just be like this, right? Does this make sense? Let's find out. I think that's good. Right, where here you do let x step be what happens, just out of curiosity here, if I make 0 to 1 and I don't float, if I do divided by 110 like that, what does this do? Okay, it does return rationals, which is, if I apply float to that, it gets the same. Nope. Map float, that's what I meant. Interesting. Okay, so I wonder if I could use this in any way to my advantage. So right here, right, I have, this is off by 1. I need the range to start at exactly 0 and end at exactly 0 without duplicates. Well, I could do what could I do? Because this is different behavior than this one. Right? This gets me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 points in the range, but the other one only gets me well, let's simplify just a minute here. Let's see what happens if I just do this. Okay, so it's divided. It's always 1 divided by an x in the x case, and 1 divided by an y in the y case, and then you just return that point. So if I do parametric grid and I want 10 and 10, yeah, okay, so that's a good start. This has to then be I can okay, that returns 1 directly. So what I could do, right, if I do range 0 to 1, step size of 1/10, that gets me that. If I conj onto that 1, oh, I would have to do conj that of into vec, or cons, I guess. Right, so that'll work. Or I could do it like this, where you you do conj onto map v float of that range 0 to 1, 1/10. You conj onto that 1. Okay, that's pretty nice actually. Maybe that's the correct thing to do. We'll see. We'll try it. Conj map v float onto that. Can I do this? Oops, map v float double float first of this one. I meant double false. Maybe they should be doubles, or leave them floats for now. That I'm not going to worry about it too much for the time being. Okay, so here conj map v float that whole range, and then you can conj 1 onto the end of that to get the proper setup there. Map v float onto this range. Conj 1. Let's try that. So if I do parametric grid of 10, 10, if I now do count of parametric grid 10, 10, that should be 100, right? 121. Why would that be? What am I missing here? Something silly, I think. 2 and 2. Oh, right. So it's going to be 121 because it's 11 points. Yes. So that makes sense. This is 10 cells, 10 cell numbers, right? So yeah, you've got a ruler that's 10 centimeters long will have 11 tick marks on it. Just like this grid, if it's 10 grid spaces wide, it'll have 11 points times 11 points there. So if I do this 10 times 5, I should have 11 times 6, 66. Yeah, okay. So that's working, I think, correctly. Now what I can do here is actually run that to create a list of points that I can use to make instead of this here, instead of calling this grid points thing here, what I can do instead is call d/parametric grid, which takes, let's do 10, 10 first, so it's a small number of points in total. So it should be a really low poly count on the, where did I mess that up? Maybe I accidentally put exactly the, there we go, okay. So that is a low poly sphere, right? And I can even change it even smaller. Right, so here, just briefly here, this is what I mean. This path, or this particular, these two triangles here are being rendered in front when they're very clearly triangles that should be under the other ones in front. So this one, like if I just delete it and I delete this one as well, it looks a little more like it's supposed to. There's weird, it's not perfect obviously. This here, now I'm deleting too many things. Anyway, the triangle order is wrong, and that is not a surprise. That should be totally normal. Let's say I want this to be 20 by 20. Should have a lot more points to it. Yeah. Yeah. Let's also go here and get rid of this. Put that back. Let's not translate it down at the moment. Scale at 0 is fine. If I fill none opacity, get rid of it. There. Slate gray. Just get it back to a more, hashtag slate gray is wrong. There we go. You know what? Let's just make it. Does gray work? Does it look okay? Black is fine. Stroke width 1. I wonder if I could do stroke width of like really tiny values. That should work because it's SVG. It'll just render weirdly, I think. Yeah. Hey, that's kind of cool actually. All right. Neat. Okay, so now just for fun, we're gonna bump this up again. Let's make that 2.5 instead of 0.5. That should be thick enough. Zoom out again. Actually, I'm not happy with that. 1.25. Perfect. That's good. Okay, so now this will take a little bit longer to calculate, right? The obvious thing, as you increase the grid size, like as you increase the number of cells in the grid, right, you're gonna massively increase the time it takes to render it, and it could be pretty dangerous. So I'm gonna see what happens if I do this, but while I wait for that to attempt, I have to go to the washroom, so won't be long. Well, that's pretty satisfying, actually, to see that. I think it's pretty nice. Okay, so what is a good way to spend my time on this? Oh, let me go ahead and update this cylinder here, actually. And I want to see what this looks like if I render, instead of the sphere, the cylinder here. Yes, it's slow because I have a big grid running over a cylinder surface, so may have been a mistake. We'll see. We'll just sit this one out for a moment and see if it actually ends up calculating just fine, but we have to see. So there's a few things going through my mind here. One is I might have to seriously think about allowing only a certain subset of render methods. Oh boy, that looks cool. Or like having stricter render limits on the client side of things versus server side. So there's sort of two paradigms in which my library, in my mind anyway, is useful. One is basically as a command line document compiler that has the ability to compile all the 3D stuff beforehand, in which case triangle heavy SVG elements are all pre-calculated basically and are just static on the HTML that's exported. That is how I create my PDF quilt patterns and stuff like that. So that doesn't technically need a crazy fast approach to doing this, although speed is obviously nice even on the client side, especially if you're doing iterative work. But anyway, there's also another scenario where the components from the stylo library I want to use in a front-end sort of thing to make mini tool applications for doing live 3D CAD programming. And in those contexts, there should be more efficient graphical approaches, and the SVG export to that sort of thing shouldn't really be calculated client side, I don't think, because it can really bog things down. I think that kind of makes sense. So let me see here. So one thing that's improved on this is that I actually do have complete coverage of the like from 0 exactly to 1, the surface is fully covered, which is good. I wonder, can I do parametric grid? Let's do, actually, before I finish that thought, what happens if I do this? What does this look like? Yeah, okay. So this is important to recognize here. The assumption I have made for my parametric surfaces is that so a parametric surface will be parameterized by 2 variables, right? And I assume that those variables map nicely onto a square grid. The ability to independently specify the grid spacing here is important because if I just make them equal, the aspect ratio of the triangles in a triangulation won't match up unless you have the ratio of the diameter to the height being 1 to 1 or 2 to 1 or whatever it's supposed to be. So for example, if this is 300, then this should work. Oh, but well, even that is not correct. There, kinda. Let's leave that at 10 and let's make this 30. Point is, the grid itself, right, it isn't gonna match perfectly. I'm noticing here I have an overlap of, I have a triangle overlap here, and that's probably because I have I've probably made something wrong at the 0 and 1 positions. I've probably done something incorrect. In fact, let me see. Let me try. Let's get rid of the conj there for a moment. Although I think I do still need it. I do want to see what this looks like if I let it run its course here. Oh, I'll have to refresh the browser. Okay, so that does appear to have solved that. Does that make sense? Is this useful? Is this important to do it that way? I think we can be okay with it for now. In fact, here, if I drop last of this just for kicks, just to see what that looks like, I would expect that drop last to leave a 1 grid gap in the cylinder, and I think that would be correct. I might be thinking about this incorrectly. There it is. Yeah, so there's a 1 grid gap. Okay, so actually let's keep that like that then. Presumably that's okay. Well, okay. So if I let's bring that back down to 100, and we'll keep that at 150. 3010 is probably not correct anymore. 4010. Oh yeah, I have to refresh this to close that gap. Did I not save it? Thought I had. Okay, well. It also might... It might be unrelated to... Oh, shoot. Okay. If it's exactly divisible by... I don't know. It's... If I do 1 over 40 and I float that, I've confused myself, and I don't know why that would be that way. Okay, so there are situations where it meets exactly, there's situations where it doesn't, and that is part of the issue. So I do think the Clojure approach is actually correct, but it's obviously not done. Let's go and add this to the issues list here. Parametric grid will give different results at the end conditions based on the nx and y args. This is related to the divisibility of the steps. I don't know. That just needs to be fixed. This is a problem that can result in gaps when mapping a grid over a parametric surface. Use the cylinder as a visual test. Example, nx equals 40, leaves a gap. Nx equals 30 does not, 25 does, etc. Okay. One day I'm gonna have to tackle those issues, but it's not today, and it's probably not on stream, because I do think that would be pretty boring. Anyway, so let me go ahead and add the conj back in here. Conj 1 onto that, so that it's guaranteed to end at 1 at least. And then, so this could be a problem. Oops. So if I take the last two of parametric grid 40, 10, see here, this is part of the issue. We've got wait, no, that should be fine, shouldn't it? This should be 41 times 11, 451 if I count parametric grid of 40 by 10, 451. Okay, I just need to figure out what's happening, because I don't understand. It might be related to when you run float over all of them. I don't know. I am unsure. Right, the last point for every single parametric grid call should be 1, 1, no matter what. That should always be true. If I do cylinder A 1, 1, maybe this kind of stuff is part of the issue. I'm not sure. Well, okay. That can be worked on as I go. What happened? Why? I think it should be working. Okay. There we go. Okay. So, things are kind of working. What should I work on next? What's a good idea? Actually, let me totally for a moment here see if there's anything that exists. This is not it at all. 3D view. Yeah, canvas. What is this? 3D view. Oh, this is not what I think it is. It's just a debugging assist thing, which is really cool actually. But that's not at all what I need. This is probably a new feature in Edge, right? I suppose so. Is it W3D? No. Web formats? No, that's not it. Web 3D. Okay. What I'm looking for is, this is, I think, what I was looking for. X3D or X3DOM. I don't know if this is a thing that's real. Let's see here, have a look here. The reason I'm just briefly scratching an itch here is, so this, right, is an element, a 3D element. Get started in 5 minutes seems pretty nice. And it uses the node structure that is also used. It's like SVG as well, is kind of the idea. So it's not in spec, but I guess probably there's like a script injection or something, right? Like, I don't want to browse that. I want to get started in 3 minutes or whatever it said. 5 minutes. Okay, let's have a look. Okay, yeah, so here, x3dom.js. Seems pretty cool. Well, so let's actually, you know what? Let's mess around with this just for a minute. I don't think this is how I want to solve these problems, but it would be fun to try something out, right? Why not? So if I go here into the resources thing of this, the HTML, I can actually just, oh, why is that like that? That's horrendous. There. Paste that in there. Nope, that's the wrong thing. Copy that. Paste that. There we go. Okay, so we've got 3DOM, x3DOM in the HTML. Should be. So far, that should cause no change. Okay, that looks good. And now, what I should be able to do is make a little component with this sort of thing here. So let's actually move this over here for a minute. 3D axes. Ah, come on. There we go. Right, so what I should be able to do is just make a component that produces this sort of thing. The result should look like that. Known an area filled with white. Let's scroll down to get a bit of a useful material spot here. Okay. Well, let's do something like this. Let's make a cone. Yeah. Okay. Let's start up here with this x3D. Oh boy, not that, this. Okay, let's go here. The names of these sections are less and less correct, but we'll start with this anyway. We'll see what we can do. So one thing that's going through my mind as I poke around with this is it's fine, it is totally fine to have JavaScript dependencies and things like that, but there are situations where I do want to be able to have my library work on user code to compile a document that is completely independent of JavaScript and still very useful. So that would be stuff like static SVG, final PDFs with no interactivity, you know. So I do need the library to be useful in terms of CAD output in dynamic viewing contexts, in dynamic app user contexts, and in static compiled document contexts, and sort of hybrids of those things. So this is not necessarily the permanent approach. SVG is really good because by default it can be used to just create nice static things, and I can use the mathematic or the geometry stuff all underneath to produce 3D things and still display them in nice 2D ways. But using those same data structures, I can have it simultaneously produce SVG and maybe something like X3 DOM, or maybe something better. I don't know. This is just a first little attempt. So let me let's define X3 DOM as a function containing no, or expecting no arguments. Here I can do this X3D, sorry, there we go, and pass it width. Let's do 500, height 500. I assume it'll default to pixels. Okay, now inside here we have a scene, and inside here we have a shape, and inside the shape what I want to do is make right away the what am I looking for here? Oh, okay, the default. Okay, I see. Okay, right. So what I want to do is make the cone, because that's kind of cool. So if I look at inside shape, there will be appearance, which inside there will have material. I don't know how I feel about this. Diffuse color 0, 1, 0. Okay, so that's the material, and that's the end of the appearance. And then inside the shape we call the type of shape that it is, which is a cone. Then that shape is closed. We're not transforming it, so we don't have to wrap it in a transform. And that should render actually when we do X3 DOM like this. Let's see what happens. Hey, there is a 3D shape. Okay, so that's That's pretty good. Let's have a look here for a moment and see what kind of X3 DOM nodes exist. Let's go to documentation, getting started, scene author. Let's see what's available here. Right, so what I want is to get to a scenario where the user has in their document built up and defined this whole 3D assembly, right? And then you can render it out. You could just call something like drawing 2D, and you get a sliced view of the front 2D of it automatically in SVG. You can do interactive 3D, and then it automatically pulls and gets this, right? And it's interactive and whatnot. And maybe it's not this, maybe it's something else. Let me shrink it down to 400 so that it's not going weird here. So what I wonder is if there's a way that I can draw triangles into the scene. What happened? It has ceased to work. I don't understand why that works that way. Let's see. Let's see. Right, this should change the color, and it's caught. So the hot reloading is it's breaking. Right. Okay. So why would that be that way? Okay, something to work on. No solution yet that pops to my head, but what I wonder is if I can actually get this same data that is, where am I here? Like this surface, if I can display it nicely in a X3 DOM right away, that would be pretty cool. Let's go nodes. Let's have a look at the nodes here and see if there's anything cool that comes out. Ball joint, really? Seems. Oh, okay. So it even has animation related stuff. Might be beyond what I need. Has Arc 2D. It's pretty cool. CAD assembly. What's this? Holds a set of assemblies or parts grouped together. Okay. CAD part. Okay. Cartoon volume style. Probably that's related to like cell shaded line rendering or something like that. Let's see. The associated volume data shall be rendered with a cartoon style non-photorealistic rendering. It uses 2 colors, and the rendering will depend on the surface normals and the view direction. Okay, let's see if they have. Okay, line set. Maybe that's something useful. A line set is a geometry node that can contain a color node and a coordinate node. Color values, or a material emissive color, is used to draw lines and points. Lines are not lit, are not texture mapped, and do not participate in collision detection. So it says collision detection. That is an indicator that this might be heavier than I need. It might be more than I need, but I'll go ahead and make a little prototype anyway because it's kind of cool. Mesh, maybe. Okay. Oh, it's an experimental. Mesh counterclockwise true, index blah, lit true, prim type triangle, solid true, primitive type triangle. Okay, that mesh might actually be what I need. Touch sensor. What's that? Tracks location and state of the pointing device and detects when a user points at geometry. Huh, cool. It does, so you could just use regular HTML events, of course, which is fine. Okay. Anchor, what's that? Grouping node. Oh, it's like a link, anchor, like an A. href, anchor, or whatever. Okay. I wonder if there's maybe some more tutorials that have different. So there's the basics, including models, animation, lighting, render performance is not what I need. AR applications, that's stuff for later. Node fields, using images in movies. Configure. Let's see what this one says. CSS even? Yeah, okay. Wonder if there's like a generic way to do shape. That's not what I need. That's pretty cool. If this were displaying on a full window, it would probably make more sense. But this is obviously useful for like touring around some 3D model you generate. So this actually is getting me thinking about different ways to sort of interact in more, you know, like fun, well, it'd be cool to have little web page outputs that people can go on and get kind of excited about the library I'm working on. That's what I'm thinking about here. Indexed face set. That might be the node I think I need. Let's see if that's let's go check that out. There's the node index, ABCHI, indexed face set and line set. Indexed triangle set would get me, let's check this one out. It's a geometry node that can contain a color, coordinate, normal, and texture coordinate node. Insert a shape node before adding geometry or appearance. You can also substitute a type matched proto instance for content. Okay. So what does that even mean? Some of this is hard for me to read and understand. I've not looked at this before, so I'm trying to parse it out as I go. So what I could do, I wonder if this works. Translate. I don't know if I'm thinking about this properly. So we'll have a quick look there. If I transform the whole shape, does that work? Got to refresh the page for this. Whoa. Something went zooming off there. That was strange. Not at all what I expected to happen. Let's have a look at the output here, because that was pretty funny. X3D, scene, canvas. Oh yes, of course, it does ruin. Maybe this is not what I need. See what happens now if I do this. Does it zoom off to nowhere again? It does. Okay, so that is not helping me. Let's get back to that. Okay, something else is going weird now. That's strange. I have no idea why it's doing that. Well, that's a little bit silly. Hey, Dr. Zonk. How's it going? Hope you're doing well. Let me see if I can fix this. How's your day going so far? Doing good? Me? Yeah, I'm doing okay. I'm trying to figure out, I don't know if you saw that. I've got a 3D rendering situation here, but for some reason it was zooming off into the distance, and I didn't know why, and now it's not, which means I have a problem that goes away, and I don't understand why. So see that it zoomed off, but if I zoom out to 100, maybe it fixes it. Your day is perfect. You got better internet? Ooh, that's exciting. Okay, so maybe that's a weird bug with Firefox Zoom. Got better internet. That's always quite nice, actually. Good internet is satisfying, to say the least. Okay, let me try this. Transform, translate. Transform, translate. So what are you gonna do with your better internet? Play, do some games online? Just watch Netflix with higher, higher resolution? Study? A little bit of everything, I guess. If I translate 100, what does that look like? Netflix and games. You know what? I'd say those are pretty good uses of some leisure time. I like both of those things. Netflix, games, fun stuff. Let me go back here and pull out a tutorial. Have a look at the hello world for a minute. Let's see what the translate. Oh, translation. That's my bad. And let's do 30. Let's refresh the page. Ah, it did work. Okay. If I do -3, sweet. That's pretty cool. Okay, so now what I want to attempt is the creation of a different shape, not a cone, but let's also translate back to 0. Instead of a cone, I want to create index triangle set. That's what I'm working on here. Triangle set. And now I don't know what to do with that. Let's see if there's maybe x3 DOM indexed triangle set. See what I can do there. Maybe there's a mesh example. I have to go to the washroom for a moment, so I'm gonna go take care of that, and then I'm gonna see if I can create an arbitrary mesh in this view here. I won't be long. Okay, back at it again. Right, so well, let's see what I've got here. Let's see if this is anything. This might be an old link. Oh, this is 6 years old at this point, so well, the issue is that old. Let's see what the latest here is. It is a closed issue, so that's fine. Yeah, okay. Let's see here. Maybe there's some documentation in the wiki or something like that. Well, that's probably not where I need to be. Let me go here and just try and figure this one out for a minute. Geometry node. It can contain a color, coordinate, normal, and texture coordinate node. Insert a shape node before adding geometry or appearance. Can also substitute a type match proto instance for content. It's experimental, that's maybe a problem. Well, what do components do here? Afraid I don't understand. Let me see. What is volume rendering? ISO surface volume data. That's different. NURBS. Wow. Well, they don't have it? Maybe they do. Coordinate builds geometry using a set of double precision 3D coordinates. X3D coordinate node is used by face set, line set, and point set. I wonder what point set looks like. Maybe we start with something really simple. It's just a point set. How about that? Documentation, scene author API. Is there a search button somewhere here? No? It's a bit annoying. Let's go see if point set's in here. Polyline 2D, polypoint 2D. What's a polypoint? Oh, it's used to build up a polyline, I guess. Okay. All right, let's have a look at point set. It's a node that contains a set of colored 3D points represented by contained color and coordinate nodes. Color values or a material emissive color is used to draw lines and points. Okay, point set. Let's try that here. We're going to do point set, and inside the point set we're going to have, it's a node that contains a set of colored 3D points let's see, X3D coordinate node. What is X3D coordinate node? What does that look like? Okay, coordinate is, it looks like coordinate point I don't get it. I don't know what the shape of it's supposed to be, so I'm gonna guess. Let's just do 0, 0, 0 for simplicity here. I don't think this is gonna work, but I want to try it. Like, there's no reason not to try, right? Okay, let's see. This have to refresh it anyway. Hey, there is a point there. Wow. Okay, so let me see. What it looks like to have multiple points. Maybe I am. Maybe I'm wrong here. Maybe it's not working after all. Or maybe it's oops. Okay, so it does look like there's a single point here. Let's inspect this. Let's attempt to inspect it. Okay, there's the scene. Shape. Point set. Okay, coordinate point equals 0, 0, 0. Let's move it by doing this. Is it valid? I can't tell. That's part of the trouble I'm having. I mean, it's also possible that it's supposed to be like this, coordinate 0, 0, 0. That's weird. Refresh that. That's not it. Let's try that. So that's not it. This is probably wrong, but we're going to give it a shot again. Okay, that didn't work. Okay. Right, so we have this kind of weird situation where we can get a point to show up, but it's not doing what I thought it would. Well, let's go x3 dom point set help. Examples. Is there anything good here? Okay. Animation examples, basics, large models. None of these are quite what I need here. Medical data, physics is in there. I don't need that yet. Visualization and CAD and simulation. See, this is pretty cool stuff. Simple CAD component editor, right? That's cool. Math learning game, nice, I suppose. What I need is just an example of a point set, and then I can go from there. This is cool. Okay, AR chess. Fine. This is not at all helpful. Seriously? Great. Okay, fine. Let's do x3 dom point set example, and we will regrettably try to search it on Google. Okay, point set demonstration. Zoom, unzoom. I see nothing. Oops. What is happening? This is so not helpful to me right now. Okay. X3 DOM alternatives. Maybe there's something else. Now I want to figure this out. Web3D Consortium. Well, okay, I'm ending up going in circles a little bit here. Yeah, I've been to this page. I'm just looking for an example to build off of, but so far the examples are all using shapes directly. So what I could do is cheat things a little bit and do like, so what I could do is something totally, probably kind of a cheat, but what I'll do here is, instead of cone, let me get rid of the coordinate attempt. Let me do here sphere. There's surely a sphere, right? Sphere. Okay. Right, so I've got this sphere here that should render, if I refresh the page, a sphere onto there. Perfect. Now, what I can do is make a really messy function that returns point x3 given some point like this. It just returns this gross looking structure here. And here the point gets turned into string this point is destructured xyz, like that. So you do x space y space z, no space at the end of that necessary. So that's the translation, and then it's just a shape with an appearance. In this case, green is fine. And then that is point x3, the messy one that I've created here. x3 dom scene zoom is probably something I need to consider. Scene. Pardon me. Children. Okay, maybe that's nothing. Well, let's instead now just go like this. Here, inside the scene here, I actually can just do for, and we're gonna do what's a good set of points? Let me do, well, actually, for point in, let's just do a list of sort of random points here. Let's do 100, 200, 1, 245, 5 of that, 100, and we'll just do one more. Let's make them a little closer to the origin here. might be okay. Right, so for point in that list, do point x3 for point. Close the for, that. Oops, one extra there. Okay, I don't know how this is gonna look, but we'll see what happens. I do wonder if the scene automatically zooms out. It does not, which is a pain. Right, so you can see the scene does exist. There are all those spheres there, but the scene zoom is not set to fill it, to nicely fill the space automatically, which is a bit of a shame. But what I can do now is have a look at where is it? Where did I define the sphere? Yeah. Okay, so I have here a sphere with a radius of 120. I want to use this and this to create a list of points that I can use in the 3D thing here. So I'm going to move this up here, and I'm going to do 25, 25. Perfect. So here for point in, map apply sphere A over the map, which is grid. So that's a list of points. It should be 3D points, and that should work. Let's see what happens. Let's see what happens when I refresh the page. Oh, it'll have to recalculate some things. May have frozen that for a moment there, but it should work. So it's going to be a huge, oh wow, cool. Okay, so it does work. That's pretty fun. That's cool. Okay, so that's obviously not a brilliant way to make point sets, right? So I do want to figure out like the proper way to do it, but that looks pretty cool, if I do say so myself. And let's actually make this 16 by 16, so it reduces the size of the, and we'll make this just 100. Save that and see what it looks like. Oh, once again, this will have to be refreshed, of course. It's pretty cool though, eh? I think that's pretty neat. Do I want to do anything with this though? Really? I'm not so sure. Actually, let me now that just I'm getting bored, so I want to do some other silliness for a minute here. Okay, a torus surface will just be a torus is a function in there's a small r and a big R. R and R. RA, RB. And then it returns a function of UV where we let U and V each be just like the sphere, this, to remap U and V into the range of 0 and 1. That should be fine there. And then we let x be some function, y be some function, and z be some function, where those functions are actually just taken directly from here. So we can just do, let's assume, ooh, wait, what is, no, I don't know which R is which. That's the thing I don't know. But let's check out the torus page for a minute here. Oh, big R is probably this one here, and little r is probably the radius of the tube, right? Parametrically, this is what I'm actually doing here. Where, yeah, I was right. Little r is the radius of the tube. Let r be 1, r be 4, print r. Actually, let's do r. Okay, that does work. For sake of that, I'll just leave it like that. Okay, so we just have x is going to be this here. X is r sine V, like that. Oop. Y is r plus r times math cos V times sine U. Oop. Times math slash sine of U. And z is r plus r times math cos V. Oh, I could have made that a let, but that's fine. That doesn't matter all that much. Times math slash cosine U. Did the math work? We'll find out. And then all you return is x, y, z. There's a vrep torus, so let's save that. And what I want to do is actually run it. Yeah. So if I go over here into this and define torus a d slash vrep torus, and it'll take big radius, let's do a big radius of 100 and a small radius of 25, So that's that, and then all that I should have to change here is instead of sphere, we call torus. And this will not work. I will have to refresh the page. And it does indeed look wrong. That's really cool, but it's really wrong, which is actually kind of fun. It's definitely a tube, but it's not doing the right thing. Excellent. That's actually kind of fun when things go wrong like that, because then you have to figure out what happened. So x can be r times sine v. R times sine v. Yes. This one is big R plus r times cos v, all times sine u, and z is that This is evidently not working. Interesting. Okay. Oh, wait a second. Maybe it is. We just have things doubling up in a weird way. See that? There's a double of everything. It's cool, but it's wrong. Now, why is that happening? Let's add more points to this and see if that reveals any strangeness. It's still not likely to work, but it's worth a shot. Oh man, I'm gonna have to get going soon. That's okay. Yeah, so it's not wrapping itself around. What have I done? So this is this surface thing here is related in some way to signed distance functions. It's different, but similar. So what I'm wondering is actually if here this is not quite what I was hoping for. Well, let's do maybe there's a parameterization of the surface of a torus. Let's see if this has anything. Let me double check this here. So what I can do, so this here that I I have these. You can change the X, Y, and Z formulas and it'll basically orient the torus on a different plane kind of thing. But what I'm going to do is just try to replicate this here. But it looks the same, really. Well, let's just to see if I'm gonna rewrite them, and if they're wrong, I'm gonna get going. I'll just leave it at that. Okay, so let's start with x is going to be r plus little r times cos math slash cosine of theta, which I'm going to say is u, times math slash cosine v. Okay, and then y is going to be very similar. Y is r plus r times cos of theta times sine of that instead. Pretty sure this is ending up being exactly the same, which then then something is not right in I'm just missing something then. It might relate to negative values. I don't know. I'll have to see. Okay, so this last one, z, is just r times math slash sine of theta. Save that. Refresh this, let it calculate. I do believe this is still not the right torus. Try one more time. Oh hey, yeah, that does work. Okay, so I just had values that were way crazy. This looks ridiculous in the best way. Oh, that's pretty weird. That's cool. I like that. Okay, so that is a torus and it is working. Let's double this to 10 and we'll make this 40. Oh yes, of course. Now I do have to refresh it, and it will take a minute to calculate, but it should work kind of. Just gotta zoom. Okay, there's a torus. Right, so now what I want to zip back down here to do is, this is the last thing I'm going to do before I get going. And I'm going to change this XF triangles here. Instead of rendering the cylinder, I'm going to render the torus A, and I'm going to go to here and render both of these into their own containers, and you should see the same data producing both the static view and the rotatable view. It will work, yes. So we have that there, which is exactly the same torus as the one that will be available to manipulate once I refresh the page. The reason it's slow is because I'm not doing anything particularly optimally here. What happened? There should be. Huh. The X3D didn't work. Try that again. It should work. There's no real reason why not that I can think of. There we go. Now come on, you can do it. Ugh, seriously? It's not quite what I thought would happen. What if I make it first? Oh, seriously? Okay. Like that. There, okay, we got, it kind of works. And then that. Okay, so the point of all of this, the point of that whole mess is that that data there, that view there is interactive 3D. It's a weird way to render it, and that's only because I don't know about the library. Come on. That's only because I don't know anything about X3 DOM yet, right? So I'm drawing full spheres for every point. That seems a little crazy. Point is, the same data structure I used to generate this static isometric view. This is SVG, and the idea is it'll work in a browser with JavaScript disabled, no problem. So I can do that here. Oh, maybe I can't easily anyway. Well, whatever. If I were to disable JavaScript, this would no longer work, but you do get the exact intent of the document still, because you can still see the shape and the dimensions and everything when you draw dimensions on there. This is just kind of a really nice sort of bonus functionality for people who love to be able to kind of interact with their objects, which is definitely really cool. But you need JavaScript for this to work. You don't need JavaScript for this to work. So that is pretty cool. If I can build a nice layer onto this or on a different library that's maybe a little smoother, I have to see. Or if I just do a canvas thing myself and make it directly on my own, I might do that. That might be a worthwhile endeavor. Then I get this really nice sort of one source creates a document that can be static, can be dynamic, and can be both, all running from the same sort of, call it a document compiler that is all this. So I'm pretty excited about this. This was fun. It was a pretty casual approach today where I didn't try too hard, just kind of took it easy and did things one step at a time and got this. I think that's pretty neat as a kind of demonstration to myself almost about how I would get things to work. And then this is obviously very exciting. Okay, pretty experimental stream today, for myself anyway. I'm gonna get going. I have to go do some groceries and stuff like that. So thanks for tuning in. If you're watching this not live somewhere else, feel free to like, comment, subscribe. If you're on YouTube, that would be helpful. If you're watching this on Twitch, thanks so much. Go ahead and give me a follow if you haven't already, because I stream 4 times a week and do a lot of programming stuff, and over time hope to evolve this into design work, more programming, experimenting with different languages, doing some more advanced math and geometry, all that kind of stuff. I think that'll be really exciting and really cool. So if that's interesting to you in any way, please go ahead and follow. That would be great. All right, that's enough for me. I am going to get going, and have a nice day.